All right, so 311 is called the secant, cosecant, and cotangent functions. It starts with evaluating these functions, which we did a little bit last week, and then it gets into graphing those functions. So when we're evaluating reciprocal functions, there are two different types of questions you could see. So when you're finding secant or cotangent of a value, then you're finding the reciprocal of both the trig function and the value. If you are finding just regular secant, cosecant, cotangent, so it would say that, it would say cosecant of an angle, or it would say cotangent of an angle, so like the angle is given and you're looking for the trig function, then all you do is find the reciprocal, like you take the reciprocal of that. So cosecant is 1 over sine, cotangent is 1 over tangent, and secant is 1 over cosine. So I think, like I said before, I think tangent and cotangent are pretty obvious, but then secant and cosine go together, and cosecant and sine go together. The letters never match. So C goes with S and S goes with C. That's if you're given the angle. So if it said something like find the cotangent of 2 pi over 3, then I would locate 2 pi over 3 on my unit circle. I would find the tangent there, which is what? What's the tangent at 2 pi over 3? Negative root 3, good. And then if I want the cotangent, I just find the reciprocal of that, which would be 1 over negative root 3, which is negative root 3 over 3. So that's if you're unit circle based. Find the angle, flip it. Then you could also get this, like let's say you need your calculator. If it said cotangent of 2.7, then I would do 1 over tan 2.7. Everything would be kept in radians on your calculator, okay? Those are the first kind. The second kind are if you are actually given the value. So if it says the secant of theta equals a number. So for example, secant of theta equals 2.7. Then the trig function comes first. You never put the trig function, the inverse of the trig function. So you never put the negative ones in the denominator. I would do cosine negative 1 of 1 over 2.7. So when you're given the angle and you're finding the value, you do 1 over the original function's reciprocal of that value. If you are given the actual value and you're looking for the theta, then you use the inverse button. So cosine negative 1, sine negative 1, or tangent negative 1. But you do that of 1 over the value. So again, you never put the negative ones, never go in the bottom, okay? From Algebra 2, that was one of the things that people get the most confused on, is when do I put it in the bottom, when not. So you're finding the inverse trig function of the reciprocal. So these questions look like this. Evaluate the function, and A, B, and C are without your calculator, and then D would be with your calculator. So cosecant at 2 pi over 3 means I'm going to find which one? I'm going to find sine at 2 pi over 3, and then I'm going to flip it. What's the sine at 2 pi over 3? It's negative root 3, oh no, negative 1/2. And root 3 over 2. So sine is root 3 over 2. Flip it, I get 2 over root 3. Rationalize it, I get 2 root 3 over 3. Good so far? All right, then we go secant of pi. So what am I actually going to find at pi? The cosine at pi, and then we're going to flip it. What's the cosine at pi? Pi would be on the left. Good, and the reciprocal of negative 1 stays negative 1. And then cotangent of 7 pi over 6. So I'm going to find tan at 7 pi over 6. What are my over 6 values for tangent? Root 3 over 3. And tan in the third quadrant, because that's where 7 pi over 6 is what? Negative or positive? Positive. So I take this and flip it. And this is where it's just like easy to remember that the reciprocal of root 3 over 3 is root 3. And the reciprocal of root 3 is root 3 over 3. So we don't have to like re-rationalize something that's already been rationalized. Good so far? Okay, then D says find theta for 0 is less than or equal to theta, which is less than or equal to pi, where secant of theta is 2.6. So I'm looking for an angle here, right? When we look for an angle, we use our inverse buttons. So I'm going to do cosine -1 of the reciprocal. So cosine -1 of 1 over 2.6. You're going to make sure your calculator's in radians because it should always be in radians. Second cosine 1 divided by 2.6. And I get 1.176. Now think about the other piece of information that they gave you. It said between 0 and pi, right? So which quadrant do I want this answer to be in? Top 2, 0 to pi, right? Does 1.176 lie between 0 and pi? Yes, so that is my answer, 3.14. That is the reference angle though. So like if 1.16, they're going to give it to you, whatever that angle is, that's going to be in the first quadrant. Then the question is, do I add an answer? So in my second quadrant, would cosine stay positive? No, cosine becomes negative in the second quadrant. If cosine was still positive in the second quadrant, I'd have to also give that answer. Or if this said from pi to 2 pi, now 1.76 is not even my answer. What I want is the positive angle in the bottom, or the positive cosine in the bottom, which is going to happen in the fourth quadrant. And so I would use that 1.176 as a reference angle. And you do 2 pi minus 1.176 to get the angle in the fourth quadrant. I don't think it's going to happen. The questions on AP Classroom have not included other quadrants, but that is something you'd have to understand. Okay, just in case it pops up, I want to just make sure I went over it. So for example, what if I had said that secant of theta equals negative 2.6? Now where should that answer be? If I went with the original 0 to pi. In the second quadrant. So I can't give 1.176 as an answer. I have to find the reference, I have to use that as the reference angle to find the actual angle that should be in the second quadrant. So I still do this, even though this is negative, I treat it as though it's positive to find the reference angle. And then I want the angle that is 1.176 away from my x-axis, which is pi. So I would do pi minus 1.176 to get that theta, if it had given the negative cosine.
How do you know when it's negative?
Because if the value, so let's say it said tan of theta equals a positive answer, or cotangent actually, because it would have been its reciprocal function. Cotangent of theta equals whatever the positive value is. What quadrants would I be looking for the answers if I didn't give any restriction? Where is tangent positive? First and third. So if it didn't give me a restriction, if it said 0 to 2 pi, I'd have to give 2 answers. If it said from 0 to pi, I'd keep it in the first quadrant. If it said from pi to 2 pi, now I have to use the third quadrant angles. So I would take whatever value it is. So let's say it was like, I don't know, let me give a value. Where cotangent would be 3, let's just say, okay? That means that my tangent would be 1/3. So I would do second tan 1/3. And I'd get 0.3. So in my calculator I did this. I'd get theta, God bless you, is 0.322. That's in my first quadrant. To get the angle in the third quadrant, it's that much past my x-axis. So it would be this plus pi. 3.462 would be my actual answer. So in each quadrant, you're using the reference angle to find the actual angle, and it's the distance from the x-axis to that angle. So if it's in the second quadrant, I subtract it from pi. If it's in the third quadrant, I add it to pi. If it's in the fourth quadrant, I subtract it from 2 pi. I don't want to spend too much time on this because I don't know that it's going to happen. I just wanted to at least talk about it in case it does. Yes? It will always give you the first quadrant. So it should always give you something that is in between 0 and pi over 2. If you use it as the negative angle, like if I kept the negative value, it's actually going to give me the negative angle in the fourth quadrant. So that's why I make it positive and then use it as though it's positive, because I think that that's less confusing. But that would be the only time that it should be outside the 0 to pi over 2 range. Okay. Most of these questions that I saw were between 0 and pi, and it was not an issue. But I do want to think about what happens if it's not. Okay. Because all that's left is all the graphing stuff. So we're going to graph cotangent, we're going to graph cosecant, and we're going to graph secant. I actually meant to check because I tried to remember. I think we did all but cotangent last year. Does this sound familiar? I think we did everything but cotangent last year. All right, so we're going to start with cotangent. So cotangent has only two differences from tangent. Other than that, it's exactly the same. The first is the direction of your actual curve goes up, left, down, right. So tangent's the reverse. Tangent goes up, right, down, left, right? That's the first major difference, is when we go to plot this, we go up, left, down, right, which means it is decreasing the whole time instead of increasing the whole time, okay? The other major difference is that where my original asymptotes live. If you think about where tangent would be undefined, on our unit circle, tangent was undefined where? Top and bottom, right? Pi over 2 and 3 pi over 2. Yes? That makes sense? That's where tangent's undefined. So where's cotangent undefined? 0 and pi. That's where your initial asymptotes live. 0, pi, and then every period away from those, it would duplicate. Everything else about cotangent is exactly the same as tangent. So our period is pi originally. If we have a b, then it's pi over b. With tangent, we find our asymptotes by setting what's next to the, like the bx minus c, we set equal to pi over 2 to find the tangent asymptotes. Cotangent's even easier. You set it equal to 0. Set it equal to 0 and then add the period and subtract the period. Everything else is the same as tangent. So this step, all right, it's going to ask this, so I want to go back over it. It's going to ask you to identify where the asymptotes are. We're going to find the initial ones, but we also have to understand what happens outside of those. And it's going to ask you your domain and range, okay? Let's do the easy one. What's the range on a cotangent curve? All real numbers, not going to change, right? If you remember your domain on your tangents, it was all real numbers except where your asymptotes live. So it's going to be the same here. We're going to find the asymptotes first, which in this case, in my parent function, my asymptotes are x equals 0 plus the period interval. So the period here is k pi. It's pi because that's where my period is, and it's k because it happens on repeat in both directions that way. So that's how we write it. Notice when they write it, they don't keep the 0. You don't have to have the 0. So these are all your asymptotes, and that's how we're going to write them. So it is the first asymptote, which we're going to find every time, plus the period times k. K isn't constant, so k could be 1, 2, 3, negative 10, and that's if like that means add your k, right? So add your period times your k means add it once, add it twice, add it 3 times, add it 4 times, or subtract it once, subtract it twice, because k can be negative. Does that make sense? Okay. Then when it says find the domain, my domain is going to be all real numbers except where x equals the same answers as your asymptotes. So pi k, or 0 plus pi k. Because it's telling you it's all the numbers in between there, but it has to skip where all those asymptotes are. And you could put a, r, n for all real numbers. Like, I don't care how you write that out. Just know that that's what that means. So and that's the parent function one. And everything else, it's all real numbers except where x equals the initial asymptote plus the period times k, or the same as you wrote for your asymptotes. So your asymptotes are where the asymptotes are where those values happen, and the domain is all the real numbers except where those happen. Step process should seem relatively familiar. You're going to find A, which is the term on the front. That's your quarter point and your 3/4 point, just like it was with tangent, but it's reversed. It starts up and it goes down. Then you're going to set bx minus c equal to 0 to get the first asymptote. Just one asymptote. Then you're going to add and subtract the period from that one. So you're going to find the asymptote to the right. You're going to find the asymptote to the left. You're going to find the points halfway between each set of asymptotes. Those are your x-intercepts. You're going to mark the quarter point and the 3/4 point. That will be your A and negative A this time. So it rises left and falls right. And then you connect those points to make the curve. They could ask you questions based on where those are. You'd have to know how to find it, but you don't normally have to find them. Yeah. All right, let's jump in. This says find the period and the asymptotes, then graph y equals 2 cotangent x plus pi over 2, and find the domain and range. Oh, let me. All right, so start with, first of all, what's the A on the front do? That means that my quarter point, let's say this is my asymptote, this is my asymptote. My quarter point, the first one is going to be at positive 2. The second one's going to be at negative 2. The order reverses, right? So it makes it a little bit taller. It's a vertical stretch by a factor of 2. Now we find our period. What's B? B is 1. Period would be pi over 1, which is pi. Then we find our asymptotes. So the first one, I take what's next to cotangent, x plus pi over 2, and I set it equal to 0. If it's tangent, I set it equal to pi over 2. If it's cotangent, I set it equal to 0. Then I subtract the pi over 2. Ada. Yeah, the period stays the same. Yep, pi over b. Yep. The only thing that changes is what we set the asymptote equal to and the overall shape, up, left, down, right. For sine and cosine, it's 2 pi over b. For tangent, it's pi over b. Okay, so now I have my initial first asymptote that I'm going to graph, which is that negative pi over 2. And then I'm going to add the period. I'm going to add the period, which is pi. X equals negative pi over 2 plus 2 pi over 2, which is a positive pi over 2. That's the one to the right. And then I'm going to subtract the period, which is 2 pi over 2. And I get negative 3 pi over 2. They should be pi away from each other. Some of the ones on the homework are teeny tiny. You can just adjust the x-axis if you want. Okay, so those are my asymptotes. For this part, I'm going to add the interval on in a second. I'm going to find the point halfway between. If there was a vertical shift, I would do it at the end. Right now, there's no vertical shift, so I'm going to leave this. And then I'm going to do my quarter point. I'm going to eyeball my quarter point and my 3/4 point. And on the left, I go up to 2. And on the right, I go down to 2. Or down to negative 2. So that's 2 periods of my cotangent curve. The asymptotes are the first one I found. So x equals, the first one I found was negative pi over 2 plus, God bless you, period k. Period was pi, so pi k. Those are all the asymptotes. The domain is everything except that. All real numbers except where x equals negative pi over 2 plus pi k. And the range is all real numbers. Or negative infinity to positive infinity. Yep. I mean, you could write out all real numbers. That's how it will be if it's multiple choice. It will write out the words all real numbers, but You can't write that in interval notation because of the interval. It won't make sense. Questions? So let's think about variations. If they put a negative on the front, what's going to happen? Flips it upside down. If they put an add 1 at the end, it does what? Shifts everything up 1. Does that impact your asymptotes? No. Does it affect your domain? No. Does it affect your range? No. All that stays the same. The only thing it does is literally take your little curve and shift it up or down if it was a minus. Okay. All right. Now we go to cosecant. If you can graph sine and cosine, you can graph secant and cosecant because it is just 2 more steps. Okay. Again, we did this in Algebra 2 Honors, but it's been a little bit. Okay. So we're going to start for cosecant. We graph its reciprocal function, which would be sine. And if you look at the curve that's there, what you don't see is the sine curve that was used to get that shape looked like this. You're going to graph the reciprocal function. Everywhere there's an x-intercept means that my value was 0, right? So if I do the reciprocal of 0, what happens? It's undefined. So all those zeros, when you find the reciprocal, become the asymptotes because they're undefined. And then if this was 1, let's say, and I find the reciprocal of 1, what is it? It's 1. So it literally starts at that point and it bounces off that max, and the same thing happens at the min. So those points, I didn't get them very close, but they actually are part of both graphs. They're the only parts that are of both graphs, your max and your min. So you graph 2 periods of the curve, you drop in your asymptotes, and you bounce your curves off the maxes and the mins. Here's where we did all that last year, okay, which obviously we'll repractice, but here's where it gets a little bit weird. Now it's going to ask for those asymptotes. It's going to ask you for your domain and range, okay? So the range this time is no longer all real numbers, right? Because what happens when let's erase this curve, like if that curve was not there, what's the lowest point on this graph? Negative infinity. These arrows point down. So it goes from negative infinity. And then it goes to a point at which it stops, right? There's going to be a gap between your parabolas. So at this one, it's at -1, which was the min of your sine curve. So it goes from there to -1. It's a solid dot because it does include that point. Then it stops and it starts again where? +1, and it goes on to infinity. So that is your range. The range is now stopped and started on these. The domain is all real numbers except where your asymptotes are. But how we find our asymptotes is different with sine and cosine. Because think about that curve. If that is 1 period of sine, how many times does it hit the x-axis? 3 times. Here, here, and here. If I was to describe this distance, it's half the period. So you just find the first asymptote or the first 0, and then you add half the period over or times k. So that I wrote it here. It is the first point plus half the period. So think sine always starts at your x-axis, right? So you find that first key point, which is going to be where you start, and you add half the period times k. Those are going to be for your asymptotes and for your domain. That's where it's going to start and stop. All right, secant only has one difference, and that is the initial shape is cosine. So now we draw cosine, which starts at 1, goes down, down, up, up. We draw it. We want to make 2 periods, so it would continue this way. I'd want to find where every x-intercept is, and I want to make my asymptotes. And then I bounce the curves off the maxes and the mins. So now where does the 0 happen for cosine? On my initial curve. The second point, which if I was going to find it, would be the period times a quarter. It also happens on the third point, which is the period times 3/4, but we're going to establish the interval by doing the quarter point. So you have to do the period times a fourth to find where your first asymptote is. And then you add period divided by 2 because it happens every half period. So this time we take the quarter point and add half the period for asymptotes and for your domain. Sorry. And it's 2 pi over b. So period, because it's based on, so 2 pi would be the parent one, but 2 pi over b would be for both sine and cosine. All right, let's see if we can graph them. So first of all, be careful because like people will look at this and start cosine and it's the totally wrong graph, right? Cosecant is the reciprocal of what? Sine. So we're going to rewrite this as y equals 2 sine 3x plus 1. So tell me what you know about this sine curve. What's that 2 on the front doing? Vertical stretch by 2, or your amplitude is 2. Good. The b is 3, so the period is 2 pi over 3. That means it's squished, right? It would be a horizontal dilation by a factor of a third. And the plus 1, up 1. Or a vertical shift up 1. Now that up 1 is the last thing you want to do. You want to find your vertical asymptotes before you shift it up. Otherwise, you're going to have to try to find your midline, which gets confusing, okay? Just find it, then shift it up. Okay, so the curve is sine, which means I normally start on my y-axis, right? And I go up from there. But in order to figure out exact points now, I would recommend, which is how we taught it last year, and somebody was like, I wish we would have just done that last week, which is, sorry. You take your period, you multiply it times a fourth, a half, and 3/4. That's how you find your key points here. So take your period, 2 pi, multiply it times a fourth, times a half, and times 3/4. This is how we taught it last year, but the AP stuff did not teach it this year, so I didn't, but should have just gone with my gut.
That's not how we were supposed to be doing it.
It could have been. No, it's not, but we didn't, we talked more about the shifts than the exact points. We didn't have a need for a lot of these exact points last time. Now you have to, because you have to figure out where those asymptotes are. So the first one is your 0, and the last one is your period, which is 2 pi over 3. There is no phase shift. We're going to do one with a phase shift because if there is a phase shift, then I add it or subtract it at that point. I find my key points and then I add onto it or subtract it depending on which direction it's going. So my first point is at 0. My first key point is at 0. The next one is at pi over 6. So I'm going to adjust these because otherwise we're going to have to squish. I'm just going to change these. This would be pi. What did I just say? It's pi over 6. Pi over 3. Pi over 2. And 2 pi over 3. I'm just adjusting them so that we're not super squished. But realize if you had like a multiple choice graph, this one would be, because it should be squished together. Factor of a third. Okay, then because it's sine, we start at the x-axis at 0. We'd go up to the amplitude, which is 2. We come back down to 0. We go to negative amplitude. We come back up to 0. So my single period, which I'm going to reflect, looks like this for the sine curve. Now I'm going to reflect it back the other way so that I have, you need to have the extra asymptotes. I'm going to wait to move it up until after I find the asymptotes, but I'm not going to forget to move it up because that is part of it. So where are the asymptotes? Everywhere it's 0. Asymptote here. Otherwise, you got to find your midline. You can do it, Dane, but I think it's more confusing because your midline shifts up. Huh? Yeah, you could do three. I would say 3 asymptotes, 2 curves at least. Okay, now everywhere there's a max, I normally bounce it off the top, and everywhere there's a min, I bounce it off the bottom, but we didn't shift it up. We now have to shift this up. So everything's gonna shift up 1 unit because of my vertical shift. And now the curves bounce off those points. They actually should physically touch those points, but you don't have to be perfect. And if you had graphed this on a graphing utility, you would see nothing but those black curves. You don't see the asymptotes. You don't see your initial sine curve. You're not going to see anything else. You're just going to see your actual curves. This guy, this guy, this guy, and this guy. Questions? Okay, so we found the graph. We answered the period. It was 2 pi over 3, but I actually have to write the asymptotes, okay? Think about your initial curve. Your initial curve was sine, right? So my first asymptote happens where on the x-axis for sine? At 0. So it's going to happen here. There was an asymptote here, which means my asymptotes are x equals, it has to be x equals because these are lines. So x equals 0 plus half the period because they happen more frequently than tangent and cotangent, right? So I have to do my period, which is 2 pi over 3. I'm going to multiply it times k, but I'm going to divide it by 2 or multiply it by a half. So 2 pi over 3k times a half is pi over 3k. It can go up top, it can go next to it. I feel like usually on the multiple choice part, it puts it on the top with it. Sure. And, oh no, this is a plus, sorry, not an equals. And you don't need the 0. If it writes it in multiple choice, it doesn't give you the 0. It writes it as x equals pi k over 3. That's how it's going to give you the asymptote. Yeah. Because your sine curve, one period of your sine curve does this, right? That means that your asymptotes happen 2 times. So it happens every half period instead of every full period. Same thing's going to happen for cosine. Dane.
So we have to go back every time we do this question on the test, we have to erase a full.
I don't even care if you erase it. I'll give you colored pencils. As long as you can distinguish to me the difference between your initial curve and your answer, then I'm going to agree to your answer. Yeah. Okay, so now what's my domain? All real numbers except pi k over 3. And my range is what? Negative infinity. What's the lowest coordinate point? -1, bracket, union, 3 to positive infinity. God bless you. Fun stuff, right? Yeah. Better than end of the day on a Friday. Good so far. Because what's left? Secant. All right, so we're going to graph this as though it is cosine. Y equals -3 cosine 2 times x minus pi over 2. Okay, negative tells you what? It's a reflection over the x-axis, so my curve's going to look like that instead of the other way around. It's going to go down first and then come up. The amplitude is 3. All right, so amplitude, B is 2, which makes the period pi, because it'd be 2 pi over 2. This time there's a phase shift, right? In which direction? Right, pi over 2. So I'm going to go 1/4, 1/2, 3/4, and then take all 5 of my initial key points and shift them to the right, pi over 2. So I'm going to do My first key point would be at 0, right? Then I take my period, which is pi. I multiply it times a fourth, times a half, times 3/4. And the last one was pi. So I get 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those are my initial key points. But now I'm going to shift them to the right, pi over 2. So I add pi over 2 to each of them. So fun. Is that what you said? Yes, I totally understand. Because there's a phase shift is to the right, pi over 2. So pi over 2. Right, 2 pi over 4, so 3 pi over 4. Pi over 2 plus pi over 2 is pi. This becomes 2 pi over 4, so 5 pi over 4. 2 pi over 2 plus pi over 2, 3 pi over 2. I'm going to adjust my x-axis so that we're not squishing this in. So this we're going to make 3 pi over 4. This we're going to make pi. This we're going to make 5 pi over 4. And this we're going to make 3 pi over 2. All right, we ready to draw the curve? Okay, it is cosine, but there's a negative there, right? Which means what? Correct. It's -3, but at the pi over 2, that's my first key point. -3, 0, +3, 0, -3. So my curve goes up and comes back down again. And as long as you equally space it out, then you can complete the curve on the other side by just following that same pattern. It's not going to be reflected because there is a shift to the right, so it's not symmetric. It would be symmetric to that pi over 2 line. So if you wanted to reflect it over there, that's fine. But as long as you follow your pattern, you should be able to get it. All right, so now everywhere there's an x-intercept, I'm plotting my asymptote. And then I'm going to bounce the curves off the maxes and the mins. So if you do 2 periods of cosine, it gives you 4 asymptotes and 3 curves. If you do 2 periods of sine, it's going to give you 5 asymptotes and 4 curves. As long as you give me at least 3, it's fine. With me? All right, where are your asymptotes? Those ones. Yeah. How do we know what this is? This is technically my first one. We shifted it to the right one. What point is that? Of these? It's my quarter point, right? So it's the second one. The first one's always your initial one. The second one, it's always the quarter point. So it's my quarter point plus half the period. It's quarter plus half the period times k. That's what my asymptote is. So my quarter point is 3 pi over 4 plus, now instead of having to do half the period, I already did it. This one here is half your period before you do the phase shift. So half my period, which was pi, would be pi over 2. Okay. Those are my asymptotes. Yeah. Because your cosine shifted. Because your cosine initial graph does this, right? So the 0 happens at the quarter point. Does that make sense? And then we shifted it. So, but if you just still find your quarter point after the shift, that will be your first asymptote. And then half the period would have been before the shift if you look at your key points. But you could also go to your period and just cut it in half. It's the second asymptote on this. Yeah, because we added this. But naturally, it would have been the first asymptote if we only graphed one period. My initial cosine curve was this. So it's the quarter point is the first asymptote from your first period. Then we added on the other one. Does that make sense? And honestly, it could be any of them. plus half the period. But if you're looking for a multiple choice answer, it's going to give you that one. Does that make sense? It could be any asymptote plus half the period. Okay. All right, so now my domain is all real numbers except,
Where x equals that equation.
good, x equals 3 pi over 4 plus pi k over 2. And my range,
It's
negative infinity to
negative 3,
-3, parentheses in a bracket, start it again, 3 with a bracket, positive infinity. Questions?